Hi, I'm Yichi. This paper is called Information Elicitation from Rowdy Cross, co-authored with Gran and Feng Yi. Our motivation is to answer the question that in crowdsourcing models, how to incentivize honest reports while dealing with the fraction of adversarial agents who can collude and mess up the system. We know that on one hand, the traditional mechanism design can handle strategic agents who are also called rational agents, in the sense that they can incentivize the rational agents to report truthfully. On the other hand, we know that the robust learning algorithm can deal with a fraction of adversarial agents while assuming the rest are all honest agents. So our idea to deal with a cross with both adversarial agents and the rational agents is to first use the robust learning algorithm to get rid of the influence of the adversarial agents while using the clean output to design truthful mechanisms. In this way, the effect of the mechanism can also benefit the learning algorithm in the sense that the elicited data from the cross has higher quality. Our model is slightly different from the classic peer prediction models. First, we assume an alpha fraction of adversarial agents whose strategy can be seen as an arbitrary mapping from their signals to their reports collectively. And we assume the rest agents are all rational, whose goal is to maximize their expected payments by report strategically. Here we assume their strategies should be task independent. First, we provide a framework that says, if you can design a mechanism that satisfies the three conditions, we have a theorem that guarantees that your mechanism is approximate informed truthful. So here informed truthfulness is explained here, which is a desired property of mechanism design. So the idea of the framework is straightforward. First, you probably want to design your mechanism that the payment for agent I in expectation over all rational agents are telling the truth should be approximately larger than a form of the mutual information between agent I's signal and the function of a peer's signals. And secondly, this expected payment for agent I, well, all the rational agents are playing an arbitrary strategy profile, should be approximately no larger than this mutual information score. And thirdly, this mutual information score should be strictly larger than some positive error. And if we can do that, we can guarantee that your mechanism is good, which is informed truthful. So we further apply our framework in two commonly used crowdsourcing settings as examples. The first one is called the general setting of peer prediction, where agent signals are assumed to be correlated, while the ground truth need not exist. Secondly, the second model is called Davis-Skinner model, where agents' reports are conditional independent given the ground truth of each task. Totally, we provide three mechanisms under two settings. The first one is naive, whose error is proportional to the fraction of the adversarial agents. The second and the third has better performance, which is smarter in the sense that they can handle an error approaching to zero with larger number of agents and tasks.